So now we'll take a look at some review problems and just to get us warmed up for that calculus feel. The first one is to take a function and determine whether it's even or odd and see about any symmetry. So from part one, we want to remember that we simply need to plug in negative x to everywhere in the function where we see x. So we replace x with a negative x. And we do that again down in the denominator. And then we just want to remember that negative x times negative x is x squared. So that gives us x squared over x squared minus 1. So what we want to realize here is that f of x now looks exactly like f of negative x. And so that tells us that the function is even. And then based on the information that we had from part one, that tells us that there is a symmetry over the y-axis. Okay. Number two is talking about the domain of a function g of x. So domain is all the values of x that can be plugged into the function, and out's going to come a real number. So taking into account what this function looks like, we have a fraction with a polynomial in the numerator and a polynomial in the denominator. When we're asked type of function, hopefully people recognize that as a rational function. Rational functions are of the form p of x over q of x, as long as q of x is not 0. And that's the second part here. Problems arise when, and then what we notice with a fraction, of course, is that the denominator can't be 0. So we want to take that into account. There's a problem if the denominator equals 0. So we want to think about what would make the denominator equal 0. So we set the denominator equal to 0. And then we see what values of x make this true. So hopefully you recognize this as a quadratic equation and it needs to be factored. So we have x. There's only one way to get two numbers multiplied together that get 2, which is 1 and 2. Everything here is positive. So that tells us that either x equals -1, x equals -2. Those are the two values that make the denominator 0. So those are the two values that if we plug them into this function g of x, we are going to get a problem. We're going to get division by 0. So what we need to do in this case is consider that as part of our domain here. So the domain here is going to be all x such that x is an element of the real numbers, but x is not equal to -1, -2. So those are the two values that would cause it issues. A really good idea with these problems is to pause and just see how many of these problems you can do on your own, and then come back and watch the video to see how I do them. But you should try to do any of them on your own that you can first. That's going to create more of a connection in your brain than just watching me. So again, from part one, we see that we're asked about the difference quotient, and the difference quotient was written in part one. I can write it down here again. But it says if you have a function, you're going to take f of x plus h, you're going to subtract the function f of x, and you're going to divide by h. Again, this comes into calculus, and that's why we're doing it right now. So the big thing that students have trouble with is f of x plus h. You want to remember that all this means is everywhere where you see x, you are going to plug in x plus h. So you might want to pause right now the video, put in x plus h, and then evaluate and see if you get the same thing I do. So I'm going to do this, and I'm going to do this, and then I'm just going to simplify. So I have 2x plus h plus x times x plus h is x squared plus 2xh plus h squared minus x minus h plus 3. So that gives us 2x squared plus 4xh plus 2h squared minus x minus h plus 3. So now I can put this into the difference quotient. So now I'm coming back down and I'm using this. So the difference quotient is 2x squared plus 4xh plus 2h squared minus x minus h plus 3. But then we're going to subtract our original function. So we're subtracting f of x. And what that means is we're subtracting that function, and that means basically changing the sign. So we're going to subtract 2x squared. We're going to subtract a negative x, which is plus x, and we're going to subtract a positive 3, so minus 3. And then we don't want to forget that that's division by h. Now, this is the fun part of this, I think, is that we get to simplify anything in the numerator that can simplify. So you'll notice that 2x squared simplifies with 2x squared, that negative x simplifies with x, and that positive 3 simplifies with negative 3. Now, the hint for this, I will tell you if you've done this right, everything that you have in your numerator should have an h in it, because it needs to simplify with the h in the denominator. That's essentially how these work. So now I'm just going to do one more step, and this can be done kind of in one step or two, so I'll do a long version, but we're going to factor out the h, or an h, from the numerator, so 4x plus 2h minus 1, don't forget that minus 1, with the h, so that simplifies the h with the h, and we get 4x plus 2h minus 1. And so that is the difference quotient for the quadratic function that you see at the top. Okay, so now match the following types of functions to their most likely symbolic representations. This is just to remind you how to kind of identify these. So you'll just do the best you can here. Again, you should pause, maybe take a look, see what you can come up with. And of course, using a process of elimination is okay as well. Most students, I'll just kind of maybe do it a student way. I think most students would probably go with trigonometric first. They'd say, oh, well, I see a cosine, so that must be A. Students would typically recognize that B is a logarithmic function because it has log in it, so they'd probably do that. Students would probably, what else? What would they do? Well, we've already seen rational, so they might go rational. They'd say, oh, rational is E because it's that fraction. And then they'd be maybe thinking, okay, what's power and what's exponential? And the quote unquote trick here is just to see that the fifth root of x is the same as x to the 1/5. And that's what makes it a power function. So that's D. And then that means that what's left is exponential. So just remember that exponential doesn't need to be e to the x. Exponential would be any base to a variable power. So 7 to the x is exponential. For question number 5, a cup of 15 degrees Celsius water, so notice Celsius here, placed in a microwave at time being 0. It's heated for 2 minutes, then it's removed and put on a counter whose temp is 15 degrees Celsius, again, Celsius. Sketch a rough graph giving the temperature T of the water at time T minutes. So this is just an example of the idea of a mathematical model. It's not specifically supposed to be anything too exact, because all we're doing is just sketching something, a rough graph. So all we want to think about is when time is 0, the water is 15 degrees Celsius. And then what we know is that it's heated for 2 minutes. So at 2 minutes, it's going to be at peak heat. And if you don't know Celsius, that's okay. You might be like, I don't know how hot it's going to be. So totally understandable. But you might be like, oh, maybe it's 40 degrees Celsius. So now we have our beginning, and then we have our peak there. And then we place it on a counter and time just passes, and so it's not going to be as hot anymore. It's going to head down. So what we know is that it probably pretty quickly heats in that 2 minutes up to, say, 40 degrees Celsius, which is actually quite hot on the Celsius scale. And then over time, it just is going to sit outside. So it's just, on the counter. And so it's just going to slowly reduce, and it should stay at that 15, right? I mean, if that's what it is outside on the counter, it shouldn't really be getting any cooler than that. And again, this is just a rough graph here. That's all. Time and temperature. So some real world mathematical model, just to remind you that that's what that would look like. Let's take a look at number 6. See if you can do that on your own, because we have already done one. So you can pause and come back. That'd be a great idea. So I'm going to put in negative x, just like I did before. So I have negative 4. Now I'm going to have negative x. And that's going to be to the third over the absolute value of negative x. So key things to see here is that the absolute value of negative x is just the same as the absolute value of x. So the absolute value of 5 is 5. The absolute value of negative 5 is 5. So that doesn't change. That is the same thing. Now, up at the top here, we do have that negative x cubed. So we want to remember that that is a negative x times a negative x times a negative x, which is negative x cubed, like this. So then what happens here is we get 4x cubed over the absolute value of x. What you want to recognize is that from the original to what came out, the only difference is that negative that was in the front. So it is just a negative version of the original, because negative 4 is positive 4. So if you really want, you could see it as negative 4x cubed over the square root of x. You could see it like that if you wanted to. But the idea is it's just the negative of what we started with. And so that tells us that the function is odd and has symmetry over, if you remember from part 1, symmetry over the origin. So in taking a look at question number 7, we notice that this function looks kind of odd. Essentially, it has different pieces to it. And so that's why it's an example of a piecewise function. The domain of a piecewise function is just like the domain of any function. It's just every value of x that you can put in, and out comes a y value that is a real number on the graph. So when we think about the domain of this piecewise, we will always start on the left-hand side. So we notice that if we plug in negative 6 for x, we do get a y value, and that continues all the way down to negative 2. But at negative 2, there's a hole. So I'm not going to put a bracket, I'm going to put a parentheses to indicate that I can go all the way up to negative 2, but I'm not going to go past it. I'm not going to go to it, And then I put a union, because now we have to think about what happens after that hole. So I'm going to, on the other side, also put a negative 2 with the parentheses, because again, I just don't want to include negative 2 in here because there's a hole. So notice that I can put in any value between negative 2, not including negative 2, all the way up to positive 2. And here's my positive 2, that gives me a y value. And then what happens after positive 2 is still just a line of y values that we can see. And those give us, for every value past 2 on the domain, the x values. And so now I can just say that this is going to go out to infinity, that every value from negative 2 on is going to give me a y value. I will never include infinity with a bracket. Infinity is, an idea. It's not a real number value. So we always use parentheses there. In terms of the range, those are those y values. So whatever y values we have on this graph. And what we notice is that the first y value starts at 0, because we have a value at the origin 0, 0. And then we move along up. So you can see that we go from 0 to 1. We do have a y value at a y value of 1. And then we have every y value between 1 and 2. And so really we're not even worrying about this piece because except for this value here, this piece along the side has every y value. And since there is a y value at 1, just on the other side, we're going to go all the way from 0 to 9 on this. And we're going to include 9 because we have the full circle. Now f of 1 is just whatever value we have at 1, which is this little value right here. And if you recognize, that's a line with slope 1/2 because you go over 2 and up 1 to get there. So rise over run is 1/2. So we have at f of 1 is 1/2 for that. Now, to do the function symbolically, that means can you come up with what the equation is for this piecewise function? And really the easiest part is the part over on the right, which is the constant line. You should see that that's the y being 2. The y values are all 2. And understand that f of x is the same as saying y. And so really what we have here is we have the y value of 2 anytime x is greater than 2. Now, the middle piece there is absolute value. So that is something really key to pay attention to, is that you have your absolute value. It's going like this, but only from -2. And not surprisingly, we're not including -2 because of that hole. But -2 to +2, we have the absolute value of x. However, it's not, 1, 1, -1, 1, 2, 2, -2, 2. You do want to notice that it has a 1/2 aspect to it. So we actually have 1/2 times the absolute value of x, and that again goes from -2 to 2. And then that long piece there is parabolic, and that just means it's quadratic, so it has an aspect of x squared to it because it just curves up. However, it's longer. If you notice that, it's longer there. So the idea is when you put in -4, you're coming out with 4. Now, if this was just x squared, if you put in -4, you should get 16. So if you put in -4 and get 4, if you put in -6 and you get 9, you should see that this is actually a function that is less than what you would think it is, those y values. And so there's a factor there that's creating the smaller y values. So it's actually 1/4 x squared. And that's, of course, from our -6, which is where it starts, to being less than the -2. And so that's what we have there symbolically. And those are just things to kind of be thinking about when you see piecewise, like what are the types of pieces that you get. Now for question 8, it just wants increasing, decreasing. The increasing is probably the easier part because it's just this little piece right here. And so that's going to go from 0 to 2. So increasing and decreasing, what they're asking for, the intervals are the x values. So we're just going from here to here. Those are the x values for where the function is increasing. For decreasing, you should notice that that goes from all the way from -6 to 0. It's increasing, but at -2, it's not increasing or decreasing because there's a hole. So we're going to say that we go from -6 all the way to -2, but then again from -2 to 0, not including the -2. When you see the constant, that's not increasing or decreasing, it's staying the same. So we don't include that in increasing or decreasing. And then the last question that kind of takes you back is thinking about a function that takes a number and takes it in half and then adds 3 to it. So if we take a number, so that halves a number, so we have a number, so our number is x here, that's the variable, and we half it, so we multiply it by 1/2 or 0.5, or we divide it by 2, however you want to call that, and then we add 3. So what you can do if you want right now is pick some values and come up with some x and some y's, in this case f of x, and then see if you can, it'd be great if you could graph that and even come up with the slope and y-intercept. So if you want, you can pause and do that now. I am going to pick some values that make my life a little bit easier. So I'm going to pick -2 here. So if I pick -2, that's going to give me -1 plus 3, which is 2. If I pick 0, I'll get 3. If I pick 2, I'll get 4. Notice the pattern here. I'm picking some values because of the 1/2 so that I don't have to deal with fractions. But you can see as I pick these values, I'm just going up by 1. And so there we go. And then I just place those values onto the graph. This should be something that students are familiar with, hopefully. And 0, 3, and 2, 4, and 4, 5, and 6, 6. And then I'm on a tablet, so do the best you can, but here is should be a straight line, as straight as you can make it. Just recognizing that what we came up with, y equals 1/2 x plus 3, I mean, it's the same as f of x equals 1/2 x plus 3. Our slope here is the value in front of the x, that's the 1/2, that's telling us rise over run. The y-intercept is a point. It's the place where the graph crosses the y-axis, so we want to understand that that's the point 0, 3. So those are some review questions from pre-calculus that are going to come back, and we're going to see them related to some of the calculus topics that we talk about.